My name is Asa'ta and this is homework 3 for circuit analysis. So, question 1 asks to find I1, the current for I1. So, to start this off, I labeled all the nodes A, B, C, and D. Next, I started with node A for the Kirchhoff current law, which is that any current that goes through one node is the same current that exits that node. So at node A, I got I1 that entered and negative I1 because it also exited A. But we can't just use that alone to find what I1 is. So I moved on to node B. And for node B, we have I1 that will be entering, have 6 MA that will be leaving, and 2 MA that also will be leaving. And I know that because these two resistors are in series and is going along these two branches and this third branch, and it will also be entering node C. There's no other current going anywhere else. So we have I1 entering, negative 6 MA and negative 2 MA equals 0. So to solve for I1, we add 8 MA to the other side and get I1 equals 8 milliamps. So for question 2 says to find VBD in this circuit. So VBD is not going along this way of the circuit, but from V to B. So this is VBD. And VBD equals VC, which is 6 volts, and CD, which is 2 volts going through this way. So adding those up together, you get 8 volts. Question 3 asks us to find VAD and VCE in the circuit. VAD goes across this way and VCD goes across this way. Because of where VAD, and VCE are, I can choose any route to take as long as it gets me, as long as VAD is a part of it. So I can go VAD, then DE, then EA, or AD, DC, CB, BA. And the same goes for CE. I can go ED to DC, or CB, BA, AE. So to find VAD, I chose to go around this route, VAD to VDE, VEA. So VAD is what we're looking for. So it will equals negative, subtracting it over to the side, negative VDE and negative VEA. Okay, and VDE is 1 volt, and VEA is 4 VX. VX equals 2V, so 4 times 2 is 8V. VDE is 1 volt plus 4 times 2 is 8. Added, we get 9 volts. And this is positive because there's a negative from subtracting it over here, and VDE will be negative 1 volts, and VEA will be negative 8 volts. And negative times a negative is positive. So for VCE, which goes across here, I chose to take the route of VCE to VEA to VAB to VBC. So VCE will equals negative VEA, negative VAB, and negative VBC. So it is now positive here because the negative times the negative of VEA will become positive. And VEA again is equal to 8 volts. VBA is negative 1 volt, but we conjugated, so it's positive. And VBC is 2 volts. So once we add all of that together, 8 plus 1 plus 2 equals 11 volts. The last question, question number 4, says, for the given circuit, if V with respect to T equals 12 volts, R1 equals 1 kilo ohm, and R2 equals 3 kilo ohms, find VR2, which is here. So we start off with writing VR2, and since VR2 is the voltage going through R2, we're going to use the resistor here, the 3k ohms. So R2 over R1 plus R2, which is here. R2 equals 3 kilo ohms, R2 3 kilo ohms plus R1 1 kilo ohm times the voltage of the entire circuit, which is 12 volts. And so entering and calculating, VR2 equals 9 volts. And that's it.